So now we'll discuss what a Laplace transform is. The Laplace transform is written as the Laplace of a function, f of t, is the integral from 0 to infinity of f of t times e to the negative st dt. Laplace transforms transform a function from the time domain to the s frequency domain, where the units of s are 1 over a second. So that means that s times t is unitless, because time is usually a second. The Laplace transform is really handy because it turns calculus problems into simpler algebra problems, as we'll get into in future videos. It is also a linear operator, which we will also get into in a future video. Let's start off taking the Laplace transform of 1. We like to write Laplace transform, the notation, using a curly cursive L. So the Laplace transform of 1, f of t is equal to 1. So therefore, using our equation that we have up above for the Laplace transform, we have the integral from 0 to infinity of 1 times e to the negative st dt. We are able to integrate this, so that would become negative 1 over s e to the negative st as evaluated from 0 to infinity. And to do this, we can use limits. So we take the limit of that as a approaches infinity. So the limit of negative 1 over s e to the negative st as a approaches infinity, evaluated from 0 to a. So when you plug in a for s, or a for t, excuse me, this function goes to 0. Because as the exponent of e gets really big, so as a goes to infinity, that term will go to 0. So then we evaluate negative 1 over s times e to the negative st, where t is 0, and subtract that from what we just got, which is 0. And that becomes negative 1 over s, because e to the 0 goes to 1. So then we have 0, because you're subtracting a negative, which makes it a positive. So that would be 0 minus negative 1 over s, or 1 over s. And that is the Laplace transform of 1. Yay, you just did your first Laplace transform. So now let's take the Laplace transform of t. So f of t is equal to t. So we write out the function. The Laplace transform of t is the integral from 0 to infinity of t times e to the negative st dt. If you watched our Remembering Calculus video back a while, you may recognize this. And we will be using integration by parts once again to solve this. So let's break up this function now into v and u, or v prime and u, so that way we can do integration by parts. So let's set t equal to u, and e to the negative st be v prime, or dv. So that means that the derivative of t, or u prime, is 1, and the integral of v prime, or e to the negative st, is negative 1 over s times e to the negative st. We can then go back and say the Laplace transform of t is equal to u, which is t, times negative 1 over s times e to the negative st, evaluated from 0 to infinity, minus the integral from 0 to infinity of 1, which is the derivative of u, times negative 1 over s e to the negative st dt. So simplifying, this becomes negative t over s times e to the negative st, evaluated from 0 to infinity. And we can factor out the negative 1 over s from within the integral, so that it is, because it's a constant. So then we add 1 over s times the integral from 0 to infinity of e to the negative st dt. To evaluate the first part, we can take the limit as a approaches infinity and plug in a wherever there's a t. So that would become negative a over s e to the negative sa. when that goes to infinity, the e value, the e term will get really small and go to 0. So that means that the whole function of that, when evaluated as a goes to infinity, goes to 0. And then when we evaluate negative t over s times e to the negative st of 0, so t becomes 0, that once again goes to 0. Then you add 1 over s times the Laplace transform of 1. So as you can recognize, the integral from 0 to infinity of e to the negative st is the same thing as the integral, or of the Laplace transform of 1. So, as we learned before, the Laplace transform of 1 is 1 over s. So therefore, the Laplace transform of t is 1 over s times 1 over s, or 1 over s squared, assuming that s is greater than 0, because if it's not, then that would affect how the limits are evaluated.